So here is a step-by-step instruction of your imaginary numbers homework. All right, so the first two problems were addressing it, and they said write it as a complex number. And so remember, a complex number is a plus bi, where a is your real component, bi is your imaginary component. So looking at number 5, the first thing we're going to do is we're going to simplify the radical of negative 16. So remember, the radical of negative 16 is the radical of negative 1 times the radical of 16. We know that negative 1 is equal to I, so this will be I times 4. We usually write it as 4I. So your answer should be 5 plus 4I. And that's your answer. Oops, for number 5. So 4I. Bam. For number 9, right, what we want to do first is we want to simplify our I squared. So remember, our pattern I to the power of 1 is I squared is negative 1, I cubed is negative I to the power of 4 is just 1. So the first thing I want to do, and I'll do this one in green, is I want to rewrite I squared. So this will be negative 5I plus negative 1. And again, we want to write it in complex form, so we got to switch those numbers. So negative 1 and then minus 5I. And that's it. That's all you had to do on those two problems. Next two problems, 15 and 19, we wanted to perform the operation between the two. So the first one is a subtraction. So what that means is I'm going to rewrite the first binomial, and the second one I'm going to distribute that guy out, the negative. And so that's going to turn my 7 negative to I positive. So combine our values first, so 4 minus 7, and that is going to leave us with negative 3. I plus 2I, 3I. There you go, A plus BI. This one, again, we'll distribute. So 13I minus 14 plus 17. And we will go ahead and we will add those numbers up. So 20I, oops, wrote that one wrong first. We got to write that guy first. So negative 14, 20I is positive. So there's our answer. Negative 14, 20I. The last one that was in this, this value was number 23. So again, we're going to add our like terms. So I'm going to drop my parentheses. And here, the addition sign is not going to change anything, but I am just going to rewrite it as a 5 plus 8, and then this will be 4 plus 3I. Right? So remember, when you are dealing with our decimals, right? I'm just going to write 5.8, 1.6, subtract the 2, line up my decimals. So 8 minus 6 gives me 2, bring down the decimal. 5 minus 1 is 4. Keep the sign of the larger number, right, which was the 5.8. So what we get so far is a negative 4.2, and then I'll add these numbers up, right? So 3.2, 4.3, and we're just going to add these up, and 7.5. So how we want to write that will be negative 4.2 plus 7.5i. So those are your performing operations, adding and subtracting. Back to 27. So 27 is we just want to write it again in standard form, so a plus bi, and we want to simplify. What I can see is that we have a squared value. Really what's going to happen is the square and the square root cancel each other out, so this one's pretty straightforward, and it's just going to be negative 10. Right? How else we can write this is we're saying the radical of negative 10 times the radical of negative 10. What's going to happen is I'm going to pull out the i's first. And what's going to happen, so we'll pull out an I, so this will be I root 10 times I root 10. I and I gives you I squared, which gives you 100. I squared is negative 1 times 10. So notice that no matter what, we still get negative 10. I believe that this way would be easier. Just take the square root and the squared sign off of each other. All right, following suit, 31 we're distributing. So I'm going to take that 4i, distribute it in. So 4 times 8 gives us 32i. 4 times 5 is 20i squared. So this will be 32i plus 20 times negative 1. Let's move our 20 in front. And then plus 32i as our answer. And then for 35, so this one's a little bit more complicated. So we cannot just distribute our exponent, so we do have to write this out twice. Be careful, there's a subtraction sign, so that means that once we multiply these numbers together, that's when we will subtract. Again, all of our answers should always be written in the a plus bi. So we multiply this together, so we will get 16 plus 20i plus 20i, and then plus 25i squared. Simplify this a little bit more, 16 plus 40i squared, and I'm going to say minus 25. And then let's simplify this even more. So this will be negative 9 plus 40i. So that's that first part. I'm going to subtract that from inside. So this will be the same exact thing. The only difference is my 20s will be negative. So I'm just going to write this as 16 minus 40i. And then this will be a plus 25i squared. So then this will be a 16 minus 40i minus 25, which is great. So minus, and then again, negative 9 minus 40i. So distributing that, so negative 9 plus 40i, and then negative and negative turn positive, so positive 9, positive 40i. Those guys, bam, bam, cancel each other out. And that is where we get the 80i from. Okay, for number 39 and 43, all it's asking us to do is find the conjugate and then multiply the conjugates together, so for both of those. And again, this kind of just makes us have a little bit of practice, so that way we know the conjugates will have our i's disappear. So the conjugate of this guy will be negative 6 plus root 5i. That's the conjugate on number 39. So in parentheses, I will put one conjugate and then the other conjugate. Okay, so negative times a negative will turn to a positive 36. This will be minus 6 root 5i. And then the two negatives turn to a positive 6 root 5i. Negative and a negative. So, or sorry, negative and a positive. Negative 25i squared. These guys cancel out. So 36 minus 5, and then I squared is negative 1. So 36 plus 5, which gives us just 41 for our answer, which is wonderful. Again, we should only have a number. Okay, here's our work for 43. So our conjugate will be 3 plus root negative 2. Again, if you wanted to write this as, we could also say 3 plus root 2i. I kind of want to do that. It makes it a little bit easier. So if we multiply our conjugates together, so this will be a minus root 2i, and then this will be a positive root 2i. And let's do the same thing. So 3 times 3 gives you 9, minus 3 root 2i, plus 3 root 2i, minus root 4i squared. So again, notice that these cancel out. 9 minus 2 times negative 1, which turns into a 9 plus 2, which gives us an 11. All right. Last three. So the first one is a little division. So we want to write it again in the form of a plus bi. So we cannot have an I in the denominator. So we are going to use our conjugate to multiply top and bottom, right? 4 plus 5i. So 2 times 4 gives us 8 plus 10i squared. denominator, this will give you 16, and then plus 20i minus 20i minus 25i squared. 8 plus 10i, and this will be a 16 plus 25. Let's add those numbers together. So we will get 8 plus 10i over 41. Now technically, if we want to write it in this form, this is how your book would want you to write it. So that way we can know exactly what our a value is and what our b value is. We can also go to the point of not putting that I next to the 10 and putting it off to the side. I would accept either answer. For this guy, for number 51, right, it's hard to tell. That is an I at the top, so I want to make sure that I wrote that out. So the first thing that I want to do, instead of multiplying this out, or multiplying by the conjugate, is I actually want to multiply by 4 minus 5i twice. Okay, and if we recall, we've already done that problem, I believe, and it was right here. So when we did that, we ended up, so 4 minus 5i twice, we got 16 minus 40i plus 25i squared. That turned into a negative 25, so negative 9 minus 40i. So I'm not going to do all that work because it's already there for us. So what did I say? I said negative 9 minus 40i, I believe. Let me just double check. Negative 9 minus 40. Excellent. Okay, and I just turned that to a square, so that is wrong. Take that away. And now I can multiply top and bottom by my negative 9 plus 40i, negative 9 plus 40i. Now, what we can realize is that as we go through, we don't necessarily need to multiply all of our big numbers together, right? So this will give you negative 9i, and then this will be plus 40i squared. Negative and negative turned into a positive 81. I already know that that and that are going to go away, so I don't necessarily need to multiply it out. But for sake of argument, let's just do that. So 9 times 40. Disregard the announcement. So this gives you a negative 360i plus 360i, and then 40 and 40 will give you 1600. My bad. So 1600i squared. So again, we know that that goes away. I'm going to go ahead and rewrite that. We know that that's going to be negative 40 minus 9i, and this will be 81 plus, 1600. Okay, so if I add those together, this technically would be negative 40 minus 9i over 1681, or we would say negative 40, 1681 minus 9, 1681, and then your I is attached to that. All right. Last question was one I didn't talk about, are fractions. So in order to add or subtract fractions, they need to have common denominators. So this is missing a 3 plus 8i, and so actually, you know what I'm going to do is, so we could do it that way. I'm going to run out of time on this one, so the next video will have this as the on it.